Caden. Thanks for joining.
Hey.
That's awesome. So thank you, Farmlab, and specifically, you know, Alex and Rachel for meeting me on early part of this week. And I know Farmlab's also been prepping this. We have a short kind of presentation that that kind of looks at the last 4 years, 5 years. I can't remember when we started. Alex, maybe you can remember.
It was the ending of 2015.
Okay, ending meaning like end of the year,
End of the year in January,
yeah,
and it
yeah,
was the beginning of 2016 when it really started to look
yeah,
into the clay.
Yeah. So, you know, just a little bit of history for those of you who haven't been part of this journey up to this point is that part of our transformation of the industrial corridor has been to kind of pierce the tarmac of a tow yard and remove the asphalt and the base and just see what happens with no further action. Many things happened. One of the things that happened is a couple of the circles retained water after it rained and didn't seem to drain. And so we probed a little deeper into the ground by asking Valleycrest to dig some of the soil out, and discovered, at least in Circle 5, the one that we're currently calling the floodplain circle, that the earth that we pulled out of the ground there to see why it wasn't draining had quite a lot of clay in it. And that clay was a very similar kind of clay when we had it analyzed to the clay that's in the Zanja Madre bricks that we have. And since the Zanja Madre bricks were made locally, it became an interesting thing to be actually touching material that was the building block of our infrastructure for the Zanja Madre, which, for those of you who don't know what that is, Zanja is a Mexican, well, Latin American term for a ditch, an irrigation ditch is a zanja, and madre is mother. So like a mother ditch would have been the main way that the unbridled river was the technology to move water from the unbridled river to where we wanted it to be would have been accomplished by the Zanja Madre to begin with. And it was a closed ditch, like it was a pipe, and it was made out of bricks, but the bricks were stabilized by the ground. So they were never designed to be like a self-supporting system. The cradle was the ground. And the lid above it was also like an arch that helped it be in the ground so it didn't get, you know, dirty. So we started to expand our divisions at the studio from optics and sonics to include optics and sonics and a new division that was called a mano, which is Spanish for by hand. And that's when Alex Tanasi started to work with us. And as somebody with a great deal of experience working with making things in clay, he was up for the adventure of actually making clay itself. So that's where we began, was taking the clay that came out of the industrial corridor and going through the process of sieving through it for the clay, separating out the parts that weren't advantageous to make clay, mixing that clay, adding water to that clay, getting it to a consistency that it could be manipulated, and starting to work with that clay. And when we started to work with that clay, the operating idea would be to make vessels that could hold water that we could put back into the industrial corridor to hold water and to stimulate living systems under the surface of the ground in arid industrial LA, to really catalyze a transformation that would be usable if you didn't have a water supply on that site, you know. So that was the idea. And we started by getting everybody's hands dirty at Metabolic. So we started by doing a workshop where all of us participated in doing Oya pots, coiled pots. And I think it was really amazing to see how immediately all of us were capable of making a coiled pot. And a lot of fun was had in shaping those pots. And then we used the hole in the ground on the moon that the clay had come from to build a firing pit to fire those pots in. And we also had fun in doing that, to sort of like sit together around a fire and tell stories and cook those pots. And from that, we right away discovered that while doing open pit firing was super fun and satisfying, it also was creating irregular success. Some pots broke right away. We couldn't really at that point know for certain that those pots would do the work that they were designed to do. But we definitely created an environment that was fun. Now, to build an open fire in the industrial corridor required fire permits, and I think we did this maybe 3 or 4 times. The result of that was that we ended up deciding that we should finish the pots in open firing for the look and the feel and the narrative development of like taking clay out of the ground there and then returning it to the same ground it came from to finish it. But we started to explore the firing of the Oya pots in kilns that we bought in the studio. And that worked better. Alex spent a long time, I think Rachel had already joined the team now too, in fixing a lot of the pots that had broken in the firing. And a lot of those went into exhibition at Descanso Gardens and have never actually gone into the ground. So we have a collection at the studio of community-made Oyas that have never been used as Oyas, but have been used as symbolic objects that tag, in a way, that whole story. But some of the Oya pots that Alex and Rachel helped fix did go in the ground. They were mostly the reject pots that didn't go to exhibition. And they have been doing some work for several years. And we have used them in ag bins. We have used them right in the ground outside Metabolic Studio in the anabolic. We've used them on the moon, mostly in ag bins there. And a week ago, I pulled them and asked for help from Alex and the team to pull them out of the ground now that everything is really dry and we're in that long summer months to kind of review where we've been and figure out how they're working. And so today's salon, internal salon, is to discuss our findings about how those Ollas that went into the ground are working, how difficult it is to pull them out of the ground once they've been in the ground, whether they fail again, because again, one of the questions in making them are, do they go in permanently, or are they something that you pick up out of the ground and take to other locations? And also to examine the size, like how big does an Olla need to be to do what? Like, are there different size Ollas that want to emerge for different kinds of purpose? And finally, how do Ollas and Hugels work in combination? So the Hugel mound is something that we've been working with on the anabolic for the last year. And the Hugel mound has something to say for it because it's already a water retention landscape. And so to combine that with an Olla makes sense because we're trying to catalyze native plants along really blighted industrial corridors. So we want our water to go as far as possible and to be not necessarily connected to property owners that could be guerrillaed into, areas that pollinators need to move along, like to be able to think about Northeast LA, for example, as a place that has lots of parks and parkland like Griffith Park, Elysian Park, Debs Park, the state park network, the city park network, and then lots of people who are using their homes to grow food in. So to be able to create corridors that enable pollinators to move as freely as possible through this territory will facilitate a maximum yield for all of those gardens and parks because the pollinators will be able to move through them. And finally, we're adding to the question of Hugels, Ollas at what size. We're adding the aspect of carbon sequestration and lead detoxification. So we know that mycelium do score higher points on the sequestration of carbon than even trees. So if Ollas and Hugels can catalyze mycelium in the industrial corridor, we will be adding a lot to our ability to sequester carbon and give off oxygen, which would be really a positive thing. But also, because a lot of the industrial corridor has lead in it, if we can support a deep cleanse through a mycelial network that's been organized to facilitate the absorption of lead from the ground, then we can also utilize that. So there's a lot of technique and a lot of refinement of concept that today's salon is about encouraging a discussion about how we can achieve our targets and think of our practice as part of a utility for our area that is cleaning up the blight and making our area healthy for all the living beings that we're trying to steward and take care of. So that's my spiel for today to get us going. And now I wanted to turn it over to Millie and the Farmlab team to help us understand their analysis of the existing Oya type, and then we'll open it up for conversation. Over to you, Mills.
Thank you, Lauren. Thanks for that introduction and just giving us the history and also teaching the new folks about the process in which we went through the last 4 years. So I'd like to welcome Alex, Tanasi, and Rachel. They're gonna first talk about the Oyas and their findings and their analysis, and I'll be sharing some photographs and some videos, and Diego will be sharing some links on the chat bar. So if you guys have any questions, again, just send us some questions via chat, and we'll call upon you towards the end. So go ahead, Alex, take it away.
Hey, thanks, Lauren, for the opportunity to work in this creative practice. It's been amazing, and it's still ongoing. And to the Farmlab team, you guys are mentoring a lot of people, not just me, and thanks for that. I guess to get into the Oya and how it works, I wanted to really quickly get into the biodiversity of it. It is showing so much effort to connect with other plants and creatures that are working with mycelium, and it's such a network that it's far more than I would have anticipated on how it's working, especially with the Hugels. The technique has been so old, it's like over 4,000 years old. It's a proven technique, and it's really unmatched even with technical stuff these days. Obviously we're in an arid area of where we live, and so air has an issue with drying out water, and it's a big source of planting with irrigation. So the Oya works perfectly in this opportunity to work inside of a Hugel. And if you guys want some more ideas on how they work, I think we know the concept of how they leach out, and it's used in irrigation. It has we could talk about the spread of it. There is an amount that Lauren wanted to talk about. What we have in the studio right now is like a 2-gallon Oya could last up to a week or more to empty out. Once it's emptied out, the use of an Oya gets better and better because of the saturation in the soil. So once it's holding, even if it's emptied out, it still has soaked the area that will last underground for a lot longer than visually we see. A lot of working with Oyas in soil is observation. Testing this, which I know now we're going to get even deeper into testing with a meter to see what type of rate it is cooling. So you could see with this diagram, it'll reach out many inches, sometimes upward to 18 or 20. There's ways that you can wicker with which would be like a string that would attach to an Oya and go down to one side of it, up to 18 inches or so. That helps the water travel. This is the same system now that we're seeing work in a Hugel that is wickering with the logs. That's why it's really important. And mainly the biodiversity of this and its entropic, new discovery seems to be an aha moment with the Oya working with the Hugels. I'm kind of quickly jumping into that, but if you guys want to talk about something, I'm happy to answer some questions about it or pass it on.
I just want to add that thank you, Lauren, also for allowing us to work together on this, and for your leadership in continuing this sustained effort and trying to understand the Ollas. I wanted to say that really the Olla project started with, I have a sick dog, so if she starts coughing, I might have to mute myself. She may have to go to the hospital. And it started with the clay, and that's what's in the background of my screen today, is the clay that we processed. And the discovery of that clay really led Lauren to conceptualize the Olla project, which she's been interested in this concept of making an image and making an object of the landscape from the landscape for a long, long time. And so what's been so beautiful metaphorically with this project is that we're literally mining clay out of a hole in the ground, firing it in the same hole, and then taking that shaped earth, that reshaped earth, and putting it back into the ground, and literally and figuratively reforming, reshaping new ground. So conceptually, I think it's a beautiful project, and yeah, I think that there's a lot more to explore with the Olla as a form and with the augmented Hugel. Sorry about the dog coughing.
No worries.
Yeah, so if you want to talk about, our findings, like a lot of this is observational, how we've been using it. And one thing to consider is that it's all site specific. So what works in one area might not work the same way in another. And it's really like how we found it. We just discovered this clay there, and how we used it and engaged with it, and how enriching that was to people. And its ability that we have this in our, LA River. So there's different ways to get the most out of it. Being in a dried area, a lower pot, it's fired at a certain temperature, will leach out or leak out. And then if you were to just take that same pot and fire it a little bit hotter, it would hold more water for a longer time. That would work better, let's say, for perennials or something. So seasonally, you can use this in different ways. That's why they're nomadic, and you can take them out of the ground and replant them in other places. They're useful. If there's one that's very porous, you can, with a certain amount of water, you can use that for more vegetation and plants like this that are more seasonal. And then in the winters, have the other pots that are higher fired that can hold a little bit more water at a longer time. The plants don't need as much water. It's really flexible on how you can design it to work for irrigation.
So Alex, can you does this Olla pot on the right, did it come out of the hole on the left?
It did. Now this came as a first practice. This only holds like 2 quarts of water. And
Okay.
This was in the courtyard of optics. And it was the first test that we did to see.
Great.
We put in, I believe it was perennials, it was verbena, and we put in
Corn.
hollyhocks. And we found out that although it did work, it wasn't enough water. It needed to be watered too many times for perennials, which now we know in retrospect. But what happened at that time, though, I don't think we have a picture of it, but out of nowhere, a corn stalk grew. And so it was still enough water to grow a corn stalk. I think the valuable lesson with these Ollas is their ability to give just the right amount of water. They can never overwater something. So once the area dries, the plants will only take from that Olla and will attach itself to the Olla. So it's really it's really not taking away the depletion of any additives or minerals in the soil, which is very important. So it really seeks the source. If you would water on top in a dried area, that 6-inch layer wouldn't last very long. It would dry. And if you overwater it, it pulls all the minerals down deeper passing the roots of a starting plant that wouldn't benefit it. So there's lots of benefits that Oya would yield to irrigation, and many different temperatures of clay that would, like I said, would hold it longer, and it wouldn't need as much, but you wouldn't have to, it's such a low maintenance and low key thing that you don't need a lot of manpower to use it.
Can you go back to the last slide where there was the hole in the ground and the Oya that I was asking about? Is that? Yeah, so those, I think those roots there, and then below it, there's like a white line. Is that white line an additional irrigation pipe, or?
No. That just happens to be in that site. There is some kind of that's part of the building. That's just a slab of concrete running through that area.
Okay.
It was noticed after. It wasn't great for a test. We didn't know it was there until we dug it out. Much as like a lot of that site on the moon, there's things underneath that we're unaware of.
Yeah, I mean, again, that there wasn't any like earth there. We removed that concrete in order to create like a little garden there. But it is interesting how strong those roots are in the left side of the left image. The roots, you can see how they did sort of start to grow into the vessel.
Totally. I mean, and taking
so they
it out.
become like one symbiotic system, and I think that's why you and Rachel were saying when we sort of redesign the Oya pots, it makes sense to not remove the pot like it's an offering. Like you put it in the ground and then it becomes part of the ground again. And in a way, it is like a well inside the ground that will have roots that wick from there into the plant. But it is really interesting to see the roots on the vessel itself.
There is, documented that, the vessels have the ability to last up to 5 years. So they're not something that you can really depend on. But if it's with a heavy root system, the roots will just, devour it, and it just becomes part of the earth again, which is fine. But so they can be taken out and used, and some can support for a long time, maybe even longer than they say. Really depends, I guess. Like I said, depends.
Woody.
There's there is still a lot of things to talk about with the minerals in the soil and how the clay, and just the clay itself. There's a lot of areas that are just made of clay and has a ionic exchange that draws in the water moisture, and the way the clay pot is working as well is that once the roots meet it and wrap it around, they don't need as much minerals from that area. They're really supported with that Oya, that they're drawing out that water. As soon as it dries up, those roots are sucking the water out. So it becomes some kind of capillary action that clay has, being an ionic thing. Just to give some information on how it supports this system.
And also, if we're thinking about native plants, then supporting them with water for 5 years should be enough to establish them so that they don't need the water after that, correct?
Yeah, that's probably really even overdoing it. I think the concept with the Oya is that it's subterranean, that the roots are going to start to grow near that pot and they're going down. Once they establish, they'll keep going down, as opposed to irrigating or watering with a hose on top where the plants are trying to reach the water by, before it dries, it's going to stay higher above ground. It becomes more subterranean with the roots within Oya. It'll teach it to really search lower. And I believe that those plants, those roots can go possibly down to water table where they're drawing water out. And we'll talk more about that because I know these guys are itching to talk about it.
Lee, should we move on to Hugels and Ollas? You're muted, Lee.
Yeah, I'm looking for the unmute.
Okay, there you go.
Again, Lauren, thank you for this opportunity. It's so exciting to get together with this group of people and have our conversations that just take us to another place. And your questions lead us into areas we didn't expect. And we keep making discoveries. And it is so exciting. I wake up in the middle of the night thinking about these things. So I'm to describe what a Hugel is German for mound. So Hugel culture is mound culture. Sepp Holzer is an Austrian man who did a lot of the work of codifying how a Hugel is made. But basically a Hugel is a construct replicating a forest floor ecology. And here are some diagrams of Hugels and different ways to look at them. What we're doing is we are passively and actively harvesting water through simple physics. So a Hugel installed in optimal conditions is an embrace capturing incoming night air, which is usually laden with moisture. The reason that the Hugel captures the water is something that we all know as kids and we forget as adults. If you want to find wet soil or life, if you want to find mud or bugs, you turn over a log or a stepping stone, and underneath that you find life. So the way we look at it in science is put carbon in the soil and the soil can hold water. When the soil has water, there's life. So this is our recreation of a passive and active water harvesting system. And what we're looking at the bottom left of the screen is our Broadway Hugel that was built with Northeast trees as a training exercise. And we built it, there we go. We always lay down cardboard. The cardboard is our invitation to mycorrhizal fungi. Mycorrhizal fungi have amazing abilities to move water laterally so that if the Hugel is harvesting the water, the plants can draw the water from the Hugel. And I'll explain that more in a moment. But what we are doing, why we call in the mycorrhizal fungi or how the cardboard works, is that mycorrhizal fungi eat cellulose. They eat dead trees, but they're also in communication and in an interdependence with living trees. They can carry moisture into a tree and in a cation exchange, take sugars from the tree. Well, we want those mycorrhizal fungi everywhere. They're hugely beneficial. Just like children will always choose sugary breakfast cereal over healthy oatmeal, mycorrhizal fungi will choose cardboard over a hard to chew log. So the cardboard is made of the cellulose. The corrugated form ensures there's air in there. It's not anaerobic conditions. And they love the glue. They metabolize that as a sugar. So we've laid down our sugary breakfast cereal invitation. The spores are everywhere. We pile on the logs and we layer that with green waste and mulch. And we want to get that biomass up as high as possible. the denser and taller we can get that, the more water we're going to harvest. So we're layering in there green waste, different things we've harvested. And this is the second hugel. We ran out of wood, so we used a lot of other materials in there, demonstrating that we can use things that otherwise might go to the dump, the frames of wooden furniture, and we want mass in there. So when you're taking a hot shower and moisture condenses out on the mirror and the window, it's also condensing out on the porcelain in your bathroom. And that's because those things have thermal mass. They're denser and they're cooler than air temperature. So the moisture is turning from its gaseous state as a greenhouse gas and liquefying. And then the hugel absorbs that. What's lovely about the hugel's ability to do that is that the logs draw in that moisture through capillary action. The problem that we have with wood is that it absorbs water. Oh yeah, but then it's not a problem when we have it in a hugel and it's absorbing water. It's a benefit. Then our plants go in there, and hopefully we have logs that have bark around them because that's where all the nutrients lie. And when we do that, our hugels the plants in the hugels will put their roots between the bark and the wood, and they will actually break down the bark and create soil from it, absorbing the nutrients from that soil using moisture that they're drawing out of the logs. So we create an interdependent system. We need the plants growing in order to activate that system. And here you're seeing that system after spending all last summer unwatered. Between the two hugels, we used 5 gallons of water. And it was really hard not to water. It was very, very hard not to water and just let those plants die if they were going to die, but they didn't. And now you're seeing them blooming, and we've added more plants since then. We're now into the hot summer again, and because of the health of the soil in and around the hugels, what we call collateral advantage. We tend to hear collateral, we think something not good is coming after that. But with hugels, we have collateral advantage. And that conferred advantage has brought in unexpected life. So in that hugel, besides those plants growing, we had a skunk. And that skunk was staying around the outside of the hugel and eating grubs. But as the health of the soil around the hugel is increasing, we now have ground squirrels. And the ground squirrels are going not just into the hugel, but into the soil under the hugel. And that's creating some drying. So as you look at this hugel now, you see it's drier than it was in the last photo. You see a log sticking out. That's where a ground squirrel family has moved in. And we now see both the skunks and the ground squirrels not just going into the hugels, but going underneath the mounds around the hugels. So our conferred advantage, the fungi that break down hydrocarbons that are living in those logs is conferring that advantage into the ground. And we're looking at things in an entirely different way. Wow, now we've got holes in hugels. What if we put Ollas in there? And we did. And you saw some of the things now thriving because of those Ollas added to hugels. There's one now. Those vines are now growing up the Broadway Street Bridge and attracting pollinators. They're taking hold of the bridge on their own, and that hugel is feeding them. But if you look at the native plants to the left in the foreground, those have found that hugel also, that Olla also, and they put their roots out. So as we learn more we will now, this next week, we'll mound soil up over that so it loses less to evaporation and more to the plants pulling it from the Olla. And each time we do one of these things, we learn more, we see more, we hypothesize, and the hive mind comes together with incredible observations. Here's our collateral advantage well demonstrated. We have Cinsuni's Hugel, or the Baker Street Hugel, to the left. We have a COVID Hugel to the right. We had to stop working on it because of our restrictions. But if you notice in the foreground, that's Artemisia californica that is just bursting with life. It is sheltering a ceanothus, a nitrogen-fixing native, and some beautiful penstemon, but it's getting ready to just lurch out of there in a really extraordinary form. And if you see behind it, you see Pete's vine, which took off with the Hugel. It found the Hugel, and the Hugel found it. And as soon as that vine began to flourish, the birds moved in. And Lauren, hearing the birds, had a wonderful idea of carrying that vine across the building. And now that vine is crossing the building, and brought up the idea of, whoa, if that works, how about we try a Hugel on top of the building? So there are 2 planter boxes up there. They have drip irrigation, but drip irrigation has drawbacks. It can deliver too much water or too little water, and requires constant monitoring up on top of the roof, which is a heat sink in the industrial corridor. So by having a low flow or a low refill on drip irrigation, but putting Ollas in there, the plants can take more water if they need it, say it's windy or extra hot, but we don't overwater them and oversaturate them. And the most exciting part of this is, as Farmlab came together, and we were delighted with this concept and with the way we worked it out among ourselves in order to make it possible and fulfill Lauren's vision. And when we let Lauren know we were up there and the plants were in, Lauren came up, and as Lauren came up, so did a hummingbird. Came right to the blooming plant and validated the concept. So magic, yeah. Any questions, I'm happy to answer.
So thank you so much, Lee. But just for everybody's edification, again, so after observing carefully over this journey of the last 4 years, we recognize that the combination of the Hugel and the Olla together are more advantageous than either on their own in this particular arid landscape. So again, that takes a lot of time to figure out, and it's only by having zones where you have compare contrast. And also really kind of one other thing to sort of compare it to is the portable wetland for Southern California that also behaves as a water cleansing strategy. So it's possible that the Hugel mound with Olla on roof scenario that captures some rainwater could become like mini wetlands on rooftops that allow water that we glean from the roof to be cleaner than the water directly off the roof that hasn't been cleaned first. And weight is always an issue when you're going to grow anything on the roof. So the idea of using native plants that don't require a lot of water and reducing the amount of water that you use by having the smallest possible oya that will support that vine is, again, once again, this kind of question of a reductive analysis of what is the right size for an oya project, and in order to do what work. So let's open up that discussion. I think that this is the beginning of this redesign question, is like, what size works best? My understanding from talking to Rachel and Alex briefly on Tuesday is the bigger pots are too big. We don't need to have that much surface area go that deep. And we also don't need to have that much water because we want the plants to struggle a little bit to establish themselves with just enough water, so that we keep our footprint in that interdependent system to a minimum. So if we're not here, they still thrive. But I wonder if there's anything that you guys have to add into that, like how big should this be, and in order to grow what?
Yeah, we had further conversations yesterday during our Farmlab meeting, and we were talking about oyas being site specific for specific vegetation. So if we're thinking of growing like an oak tree per se, then we would actually go for a bigger oya and allow that oya to actually become a symbiotic relationship with that tree. So don't remove that oya, allow that oya to break down and go back into the earth, as opposed to growing a lettuce. You know, a lettuce plant doesn't require that much water, and it doesn't require that big of an oya. So I would say that oya would be probably a gallon's worth. So we were trying to determine, you know, how many gallons per oya. And I think that after lots of conversation, Rachel and Alex determined sizes yesterday. You guys want to talk a little bit about that?
You know, like you said, like 1 gallon would be sufficient for like a lettuce. And I'm seeing that with perennials, if you have like a 2-gallon oya, that's sufficient. If it's also the amount of time that you want to put into this low maintenance type of irrigation. So if it's a 2-gallon, it could be up to 2 weeks that you would need to go to it. Possibly even longer, because once it's empty, it doesn't necessarily mean that it's you know, dry underneath the pot. So you can, and if you'd go any bigger, I think I'm reading more that perennials and things that we're interested in, the pot could possibly be cooked a little bit hotter, so it's not as porous. It'll hold water longer, but it's also a 2-gallon container that would, you know, have a sufficient amount of water for it. And like you said, it's going to draw it out and when it needs it. You know, if you guys want to talk about this is where the pot came out of the Hugel. And I know there's a lot of conversation that we had, not only on determining size and stuff, but what you're seeing here is a picture of the mycelium growing and with the ability of the oya being in there. James, you want to talk about that?
Yeah, sure. I think I can answer some of, or at least lay some guiding direction of what we're trying to do in Farmlab as to how to assess this symbiotic relationship, this nice synergy between oyas, mycelium, and Hugels. And we can talk about the testing we're going to do, but I think also first, I prepared a little thing about how those three specifically work in conjunction together, and then I'll talk about the testing we're doing. Like Lauren said, like to kind of create this system with the same rigor that we created the portable wetlands, to look at the minimal amount of energy and water and input resources we need to catalyze living systems and biodiversity before we can remove ourselves and kind of let them sort of, you know, take back the industrial corridor. So, oops, here we go. So here's a little drawing of our hugel and what we're observing. We got some corn, we got an Oya, we have these hardwood logs in the middle, pollinators, sunflowers, all sorts of biodiversity going on in this system, both above ground and below ground. And so the first thing, kind of just to recover what Lee was talking about, is that the hugels are trapping moisture through thermal mass through the air. They're storing rainwater, and they're providing food and water consistently to plants and fungi, while also being decomposed to sequester carbon into the healthy soil. And then when we sort of zoom in on how the mycelium play, even though each of these slides are all interconnected, what we're looking at is that anywhere where there's hardwood and there's water, you will always find mycelium. And that's a particular challenge in the arid climate and the industrialized climate that we exist in now. So the logs and the Oyas provide the necessary water for the food and fungi. In turn, these plants and mushrooms and the mycorrhizal fungi form these networks that then begin distributing nutrients and water to the rest of the hugel ecosystem. And then also with water, with crop cover, mushrooms start forming. Those provide food and habitat for insects and pollinators. And then one other thing that's really special that we wanted to cover was that when you get mushrooms, which are kind of always the superstar, we want to also highlight the mycelium, but the mushrooms do this amazing thing, which is that spores actually create wetter environments. So underneath the crop cover, in sort of the zone between the leaves and the soil where the pollinators and the mushrooms and the dirt is, it's creating wetter climates through the spores. And actually there's scientific studies now that are showing that spores actually contribute to cloud formation. So they're these kind of micro wet particles that are always floating around and making their environment. So again, this is part of that system of hugels, Oyas, and mushrooms that, again, is catalyzing biodiversity and is synergistically putting back in water into this system. And then lastly, we're looking at focusing on the Oya. So obviously, mycelium forms around the Oya to draw water and minerals from it. Oyas bring plants, which are creating the crop cover, conserving both water and inviting fungi. Plant roots are seeking out the Oyas, driving them deeper into the ground, creating longer roots. Any excess water that's dripped out of the Oya goes down to recharge the hugel logs. And ultimately the Oya serves as the symbol, as a node of interdependence perhaps, where you'll find mycelium, plant roots, and insects all coming together in these one hotspots. And while that might happen sort of out in environments without our help, in these desecrated environments, Oyas really serve as this artifact that we can give back to create this genesis of biodiversity. So that kind of gives an overview of the way hugels, mushrooms, and Oyas play with each other. And just briefly wanted to talk about how we're going to go about assessing some of this. So this is somewhat known information about the effect of how deep and how far the Oyas are actually creating moisture. And so we want to study that effect with distance and time with ours, because our clay is unique. But ultimately, we also really want to get deep into how it's affecting the life web at different intervals. So looking at different sizes, and context to different types of species, different types of materials, like if we had a floodplain hugel, or if we had a hugel that was for oak trees, or a pollinator hugel, and the list can kind of go on. But what we really want to determine is, if we give the Oya, if we were refilling an Oya only once a week versus we're refilling it every 2 weeks, or maybe even once a month, what's sort of the sweet spot where we can kind of put in the least amount, but with the greatest effect. So in this system, we would be studying the fungi, the bacteria, the mycorrhizal networks, the nematodes, and the eDNA biodiversity, which will tell us how the insects and arthropods and pollinators and even other larger organisms, larger mammals, are coming back to these environments. And so again, the idea of this is to try to create a create a system of rigor that really tells us how we can use these, this combination, this synergy, to really catalyze the life web. And yeah, I also just wanted to touch on sort of the, we're focusing on the sort of biodiversity, the intricacy, but also we are, there's an important note here that Lauren brought up, and Lee as well, which is the bioremediation. And in all of those systems, we're kind of like, as Farmlab, looking at this, you know, we're looking at phytoremediation, mycoremediation, but in larger, we're looking at eco-remediation, which is the idea of, if we bring back self-generating living systems, we're bringing back plants that are pulling out lead, we're bringing back mycorrhizal networks that are helping them pull out arsenic, and we're bringing back oyster mushrooms that are degrading petrochemicals, and even to the point where maybe we could take these kinds of Hugels and you could water them with LA River water, because perhaps the right ingredients are there to cleanse the soil, the clay, the plant filtration, the mushroom filtration. So these are the things that we're trying to create a system of rigor to really understand and use ourselves, but also, you know, export and share with other people, telling them what are the needed ingredients. So thank you.
Thank you, James. James, Lauren had a question. Lauren, you want to ask your question?
Yes, I have a couple questions. One is, when in your beautiful drawings, one thing that wasn't there that I wanted to ask you about is, in order to catalyze the interdependent kind of magic that happens between plants and mycelium under the ground, do you need to have apertures or light straws in order to facilitate that, or do they do their own magic without available light?
That's a great question. I think it's contextual. So if we're looking at like, you know, building a Hugel just on the surface of the LA riverbed or some other abandoned zone in the industrial corridor, they'll get enough light that they need from the plants on the surface, and in that case, they're probably diving down somewhere around maybe at most 15 feet below ground, which is definitely enough space to get to the lead and some of the surface petrochemical contamination. So the light is actually the light is important because the light is being converted by the plants into sugar, and then that is being traded through those mycorrhizal networks. So those networks of mycelium and roots are actually distributing, in a weird way, transformed light into sugar throughout the networks. But I think something that you and I have talked about before is, what if we're trying to look even deeper to, let's say, you know, 30 feet below ground, where we're almost touching the water table, and you know, life doesn't really exist in as great of abundance 30 feet below the ground because there's less oxygen. So you kind of get more organisms that thrive with less oxygen, and they're not as prolific as aerobic organisms. So in that case, we've been thinking about having these light wells that maybe perhaps bring light down, and also allow oxygen to travel down, and sort of like maybe on the sides of these cylinders or whatever shape they are, we have plants growing through them, and have sort of these pockets of logs and different substrates that mycelium will attach to, that water will be absorbed into. So in that case, I think there's something really interesting to explore with these light wells, to really bring light to the sort of dark legacy of petroleum that's deep below ground.
Yeah, like that's something that we're working on and hope to work more with you on, James, on the Bending the River step wells that are inside the pit. Is that as we go deeper into the ground, we have sort of designed basically mesas as you go down that could bring light to the water table, potentially. But one of the sort of interesting things is to think about, you know, the hole in the Oya where you add water. I'm thinking, could there be like a double chambered Oya and sort of like nested Oyas, so that the water doesn't actually go in the Oya, but rather light goes into the Oya, and they almost sit one on top of each other, like, you know, you'd form like a chain of Oyas. They nestle, so you're making these sort of, the places that you put water would normally would actually be light, and then there could be two walls to the belly of the Oya, and those walls could have plant life in them. So if you add Oya, if you add water into those, they could create the catalyzation of the plant mycelium bonding that would start the deep cleanse. So I was wondering, I mean, this is sort of what I hoped that you and Kaden could explore, is whether, like, if we go back to the image of the Oya, we don't have to go back to it, but we have it in our mind's eye, of the Oya that's been in the ground for several months. If you had an Oya that had been in the ground for several months and root systems had already been attached to it, could you then sink into that Oya another Oya, or sink around it another Oya that had some kind of ability to create and catalyze the mushroom plant symbiotic relationship that would allow for mycelium and plants to thrive deep in the ground, where we need to clean up either water table pollution or higher up lead.
Yeah, absolutely. I mean, I think that's a really inspiring idea. Most of these, you're kind of describing like what in remediation is described as a bioreactor, but typically these are made out of more quicker biodegradable materials like bamboo or agricultural waste. But I really love the idea of using clay and also bringing in the aspect of plants, because most of these systems just use either bacteria and mycelium, and usually they're kind of like a short-term system. Even though they're beneficial, they all just degrade into soil. You kind of have to keep refilling them and keep putting them in the ground until the oil has completely disappeared. Whereas I think if you bring in sort of the aspects of plants and the sort of support that plants bring in, always channeling food through photosynthesis and light, that could really catalyze and basically create a new source of energy for other microorganisms to perform a much more long-term remediation on these sort of underground areas. I think that's there's something really powerful to be explored in there, and I think bringing plants and clay into it is something that hasn't been done before, and is something that's being asked to be explored.
Okay, we're at the end of our hour, and we're just beginning to get to the redesign. So since we will continue that discussion within Farmlab, I just wanted to see if there are any questions from the studio community or design observations that anybody wanted to throw in for us before we go into a redesign.
I just had a quick question, just thinking about this idea that James was talking about of sending these light wells down and opening air and I understand this is like a remediation technology that, you know, an idea to sort of try to address these petrochemicals in the soil. But is there any worry or concern? Because one of the things that strikes me is that this isn't like, this would not be like a quote unquote natural situation, and to be introducing oxygen and potentially creating an aerobic situation down near the water table. Like, have you talked to people? Are there any risks associated with that to the natural sort of ecosystem?
I mean, yeah, that's a good question. Yeah, always should be considerate of how we're affecting our environment. I mean, I think the main thing that kind of I think ties up that question is that as soon as you remove light, like let's say once the job is done, right? As soon as you remove light and oxygen and plant and stuff like that, that environment basically reverts to what it was before, which is mostly anaerobic organisms, which are constantly being flowed downstream from the sort of the groundwater and whatnot. I mean, I can't say I know a terrible a terrific amount about sort of, you know, the ecology of like deep anaerobic organisms. But I can say that basically all you have to do to revert the environment back is remove oxygen, because all the things that shouldn't be there won't be there anymore. And in terms of like, if we're thinking about like, what if plants and spores and stuff are falling into the groundwater? And that's kind of a thing that already happens through the process of decomposition. And, you know, if they flow further down, they'll seed environments where they're supposed to be, where there's oxygen, or they'll just be broken down by other decomposers that live in a oxygen-free environment. I don't know if that kind of answers, or if anybody else has anything to add about that.
Well, also just to say, Tristan, the work that we're doing is got no available prototypes. So it is truly, I've looked for a few years, and the reason why I invited James to be part of the full-time team is that I think as far as we're going to get is asking questions to people who dig big holes in the ground all the time, because we're constantly mining for resources, which is opening up the inner earth for all of the junk that's in the atmosphere to be below the surface. It's like kind of almost synonymous with our economy is extractive industry.
Right.
So I think that these portals,
it already happens all the time. In other words, is what you're saying.
Yes, and there's been pretty much no
in exploitative and extractive ways. Yeah.
So we're talking about are like almost miniature apertures in comparison to what every time people build a foundation for a house or a building, what they're doing.
It kind of, what you're proposing kind of reminds me of like acupuncture in a weird way, because it's like sending these needles of light and air down into like certain critical points in a distressed system.
Yeah, I think you described them as that at one point, Lauren, as like acupressure, or needles in the ground.
That's definitely kind of the idea is that to stimulate to stimulate self-propagating feedback loops that feed the life web, you need to get light and moisture to mycelium, which seem to be the front guard of recatalyzing what's needed. And again, the reason we're looking at that is because we're getting ready to build a big pit in the anabolic on top of petroleum and lead compacted soil. So in thinking about what we can learn and is a question about like, how do you set up the experiment? You know, because by nature, it's going to just be an experiment. We're not going to get to the answer before we start construction. And the cleanup job might take a couple hundred years.
I think the other thing that's an important point is that, you know, in terms of like thinking about natural systems, the ship has already sailed on that point for this site. Like, you know, that it ceased being a natural situation when it was soaked with petrochemicals. So that's the inheritance of this site.
Right. This is like the industrial corridor. So there's every kind of interference imaginable with the natural condition of the floodplain. And so like behind all of this is our advocacy for the floodplain, which is buried underneath all of this stuff. And what we've noticed in the 9 months since we brought the floodplain out from under the ground is that just by adding light and water, there's very clear life inside of the floodplain. But so one day the concrete will be gone with or without us, and all of those positive attributes that are in the floodplain will be there. But next year, when we start under construction again, we're going to be pulling, like, I think 25 to 30 times what we've already pulled out of the river, and we would like to activate it in the industrial corridor as part of this concept of utility. So thinking what we actually have going on at the moon, where the floodplain is essentially a Hugel made out of floodplain, because we've put a mound of floodplain on top of concrete. So the base of that circle where we have the floodplain is the concrete floor of an old building. So then we piled the floodplain on top of that, and Sal and the guys made a little stream that can flow around it. And for several months, that stream circulated. And now if you go there, you'll see where the stream circulated, there's a bunch of baby willow. So that willow isn't anywhere else except for where the water circulated. So the idea that you could potentially replace the circulating water with Ollas, right? So if we built a new Hugel mound of floodplain and added Ollas instead of circulating water, it would be interesting to see what happened. So one of our next actionable steps is to decant those 3 tubs of floodplain and build log and debris Hugels and pour the floodplain on top of them with Ollas in it. And we'll do 2 different kind of studies with the same kind of Ollas. We'll have one that has like twice as many Ollas as the other, and we'll see how they compare, because all of the seed bed appears to be ready to be reactivated with moisture and light. So that's why I'm saying all of this is so empirical. It has to come from observation, and we're just so fortunate that we've had this time to observe these things, because like now I'm wondering if we talk to Gladding McBean about the pipes we're getting made, which are vitrified clay, whether we can make little weep holes in the pipe to let some of the wastewater leak out of the pipe in key locations in order to get some of the floodplain wet. I mean, again, this may just end up being a drawing. Probably will, because I'm not going to spend another year going back to the going back for permits for this. But it would be great if we prototyped it so that people could see this, because it's all right now invisible and it's really hard to advocate for something you can't see. But since we have floodplain on the moon, we're going to be using the floodplain with the Oya in a Hugel context to explore that, as well as along our eavesment outside of the moon, so that we can grow native plants for the unhoused community to glean their own medicine. So those are some of our targets, and we can observe how that's going because we've got native plants growing there for 4 or 5 years now. And places where they're receiving water through irrigation, we're giving the circles, clearly look different from places that are not receiving water. So I just wanted those of you on the larger team to actually know what we're doing in Farmlab, because it's really careful, empirical, experimental work. And sometimes you just see the plants that are growing on the top and it looks pretty, but to get there, there's a great deal of discussion. And I thought that it would be helpful to have this discussion before we start Q3, because we will be remaking more Oyas, but they'll be standardized and more regularized and almost entirely invisible. So you won't see almost anything on the top. And so we wanted to share that and get any questions. And also, this will be a great document for our website, I think, so that people know, based on our Farmlab newsletter, the last year of work that has gotten us to understand the Hugel and the floodplain. We're now going to put the Hugel, the floodplain, and the Oya together and kind of take it farther. So thank you, Lee, for all of your expertise, and James and Alex and Rachel and Diego and Millie, and God, who else has been working on this? Bees and Kelly and Jaime.
Roxanne.
And Roxanne.
Michelle.
Michelle. It's very, I think it's really exciting work, and I'm really looking forward to taking it to scale. And thank you, Walker, for inspiring me to think about the pollinator corridor in relationship to the bees. And I was hoping you could help us with the plants that we should try and put into these Hugel, gorilla Hugel mounds that will help the bees and other pollinating insects to move through the industrial corridor more freely.
Do we have time for some other questions? Because I did compile some of the questions that were...
Let's do it. I mean, luckily Zoom takes, we can take as long as we want. So let's go through the questions. People who need to leave, please feel free to leave. But I think this is a good time for me, at least, and the Farmlab team to get as many questions as we can, because they're really helpful.
Cool. So Caroline asked, do you need to redo the Hugel once the logs are decomposed? I think that's a question for Lee.
So it takes about 20 years for a well-built Hugel to decompose. And because all of that carbon is still in the soil, it will still have benefits even after 20 years. So it's a relative question. Everything is site specific. It depends on the wood you use, the amount of materials, but it has long lasting benefits regardless.
Cool. And then we also have a question from John that says, that asks, do Hugels work in any climate?
Well, I learned in the Mojave Desert entirely by accident. We had a forest fire or a desert fire that burnt down my pristine mountain, 5,000 foot desert land. And my grief was huge. All I could do was arrange what had burned. I couldn't stand to see it standing and charred. So I knocked it down, and I did, like, before Andy Goldsworthy was Andy Goldsworthy, I was making patterns in the desert out of burnt logs. And I had a hunting dog that would bring me rocks. And so I incorporated the rocks and the logs as tributes to where the trees and shrubs had stood. And then I had children, and then I had no time, and I built a cabin, and I didn't notice what was happening for 13 years. I then went up in a plane, flew over my land, and said, that's not my land, that's someone's farm. What I had done inadvertently to process my grief had harvested water in the Mojave Desert. So yes, it can work anywhere. It works better in some places than others. The assist of the Oya is tremendous. That's just a fabulous assist. And one of the things that came up in one of our brainstorming sessions, when Lauren suggested, how does this relate to the floodplain? A hugel is literally what happens when the river floods, knocks down trees, and mounds it over with debris and rock. That is the floodplain, and that regenerates life. So it's particularly relevant to the floodplain. The thing that we are demonstrating is that it also works in a Mediterranean climate. And our climate is continually getting drier at this point. We are becoming more of a monsoon climate. So the fact that the hugel can also act as a living sponge and absorb that moisture when it falls is relevant. But it will work anywhere. I've done it in the Mojave.
Thanks, Lee. Philip had one question regarding oil engineering, so I'm gonna let him ask that question.
Hey, when you guys were talking about different sort of different plants requiring or liking or needing water at different depths and at different rates of feed, and therefore firing clay in different ways to be more or less permeable. I was wondering if you'd explored different ways of making, if you wanted to water a deep area, I'm just thinking you bury a big Oya, and if the top part was either by a glaze or some other method made impermeable, you could have a larger reserve of water to feed at a lower depth. I don't know if you guys had experimented with something like that, but just wanted to toss it out there.
I kind of know what you're saying. You want to know if it's glazed at the top, if it's going to retain water more for a longer time, right?
To not leach out water at a depth that you don't want it to leach out, and to therefore just have a smaller surface area of permeable Oya at a depth that you want it to leach out.
It would definitely do that. You're reducing the area where it's going to leach out, and how the Oya normally would, like we showed a picture earlier, it's kind of more of a rounder area that it soaks underneath. Is like it's going to soak less underneath and more on the sides. Yeah, so if you reduce it, yeah, you can single it out to where you want that water to come out. And I know that there's modern techniques too, where it's almost like a tube with a cork in it that's just ceramic, I believe, and it's only leaching out where they want it to come out. Yeah, so you know, but it does, when you mention that, there's advantages at something so simple. If you did glaze it, let's say if it was out of the ground, we've mentioned about capturing dew, and that's one way to introduce water into the Oya, by making possibly a larger lid on it, or a lip that's glazed that would draw in moisture. But yeah, so it's totally open to any kind of possibility, I think. Super resourceful and easy to work with.
Thanks, Alex and Phil. So the last question I have on record is from Lauren. So she asked, what about adding things that have been painted into the Hugels? Is that a possibility?
I can tag team this one with Lee if you want to go first, Lee.
Yeah. If you want to grow food, you wouldn't do that. But in a garbage hugel, which we might do for a pollinator hub, that we're not so concerned. One of the things that happens when moisture goes through wood is that it creates humic acid. And humic acid breaks down compounds, many compounds that don't break down easily. So I wouldn't put that in a hugel for food, but I would consider it, and you experiment and test. But for most hugels, I would avoid glossy cardboard and painted wood.
Right. Yeah, I kind of agree with the sort of food versus maybe more for remediation or kind of just letting something be for pollinators. But some of the like little micro observation experiments that I've done with Caden in the laboratory is we set up a liquid culture, which is just mycelium growing in a liquid state, almost like a kombucha, and mix them actually with different types of paint, which is odd, but there's a lot of study that's been done on fungi's ability to break down particularly petroleum-based paint products. And so, you know, I can get pictures of it, but if you are ever at the studio or wherever at the studio, you know, whenever that is, you can come and see a turkey tail mushroom that's growing through some bright purple dye from the print studio and several other ones. So it's pretty fantastic. So that's something you could think about if you're thinking about how to recycle this like sort of waste stream.
Thanks, James and Lee. Those are all the questions that I have. If anyone else has any questions, feel free to shoot them out, but that's it on my end.
Thanks, Diego.
Thanks, Diego.
Okay, well, thank you everybody for joining in. Next week is the last week of quarter 2, and in quarter 3 we're going to be beginning a new Oya project, and it'll be based on the moon in the ceramic shed, so it's open air. So if anybody is interested in getting their hands into clay, please let Millie know, and Alex and Rachel and I will work you into safe social distance Oya fabrication for the for quarter 3. And again, we're working on a design that's standardized. It won't most likely be coil pots. It will probably be sheets. It'll probably be sheets of that are pressed into molds. But it's still quite a labor-intensive project that involves sieving and a whole bunch of other things through our clay, and we could use the help, and that also means there'll be some ongoing experimentation as well as helping us with observational, if you think your skill is observational, watching the floodplain Hugel respond to this new, it'll be more like adopt a floodplain Hugel. There's a lot to see, so we could use the help, and obviously we'll also be exploring the idea of this as part of our utility. So shaping a new kind of urbanism for the industrial corridor, using debris and gleaned roof water. Exciting stuff. And it takes time. It was always, that's why I wanted to contextualize this today and activate our archive. You know, five years. The moon is a 5-year-old project in terms of what it looked like 5 years ago, and the moon and the Oya project started sort of at the same time. Actually, I think the moon is older. Might be 7 years. 6, 7.
The moon is 5 years old.
Okay.
And the clay is 4 years old. Yeah.
Okay. Yeah. So they kind of, you know, this idea is now going to kindergarten.
Wow.
After 5 years of free-form play dating.
Well,
And again, I've looked a lot out there into the world, and I think this is really not something you can find. There's occasionally you get to things that just aren't online. I would say this area of Hugel, Oya, mycelial networking and interdependence is not available. So it's an interesting area, and I think that it's publishable. So that's why I wanted to send you guys also out our first ever Farmlab newsletter, so you could see how we're presenting our ideas at this point, so that it feels less experiential and more like something that can be published in a educational journal. So before we sign off, if there's any questions on the Farmlab newsletter.
I don't have a question, but I do have a comment. It's been awesome. Your vision on the moon, and to see the transformation in the last 5 years has been incredible. And to be working with this team is pretty remarkable. We've definitely stepped it up, Lauren. Thank you.
Thank you. I'm really happy with the work that we're doing with Farmlab. And again, oddly enough, our productivity has definitely not decreased during this quarantine period. In fact, it just sort of sharpens that sword about working to scale and thinking about making self-sufficient, self-propagating, self-generating feedback loops that don't require us to take care of them.
That's right.
Okay, well, thanks everybody for joining. You can unmute yourself and say whatever you want to each other on the way out. Thank you, Farmlab.
Great job.
One last thing I wanted to say was that I thought that metaphor of like mushrooms generating clouds, you know, and then thinking about your cloud parade, and just this idea that this Hugeling and augmenting the Hugels with the Oyas, that you could actually create weather, a different weather pattern over the studio eventually. Metaphorically or visually, it's kind of like, it's a very powerful image.
Mm-hmm. Mm-hmm. And your hat, Rachel, your what was this hat?
The background?
That's the LA River clay.
Wonderful to be with you. Beautiful.
It was so great to see everyone. Thanks for having us.
Thanks.
It was very inspiring.
Thank you.
Awesome.
Thanks, Ryan.
Hi, it was great.
Thank you so
Eddie
much.
Walker.
Bye, guys.
Guys,
Thank you guys.
I'll see y'all for choir.
Okay,
Hey.
Yeah, see you later.
We got a yodel for Hugels. Beautiful.